Libby, what kind of inequality did you get for the third one down?
I got y is less than or equal to negative 1/2 x plus 2.
Good. So don't forget to divide everything by that 2. So we're going up to 2, and then down 1, right 2. She said less than or equal to. Sabrina, how about the fourth inequality? What does that become?
Y is greater than or equal to x minus 1.
So sign flips when you divide by the negative. It's now greater than or equal to, down at -1. What's the shape of our graph? Our shaded region, our bounded region? Brandon?
It's a little tiny piece in the center of above x equals 0.
Yeah, so it has to be above x equals 0. And it's this little shape here. So it's not a triangle because x is equal to 0 gives it that flat horizontal line at the bottom. So that would be a quadrilateral. It has 4 sides. But it's not a specific quadrilateral. It doesn't have 2 pairs of parallel sides or anything like that. Just a quadrilateral. So in order for us to find the maximum value, the max and the min values are found at the points or the vertices. So we have 4 different vertices or areas where our 2 lines are intersecting, and will always be found at one of those vertices. The middle values are always in the shaded region in the middle of the graph. So if we look at those vertices, one is at 0, 0. That would probably give us our minimum value, because if you plug a 0 in, you're going to get nothing. How about another ordered pair? Should be 4 of them. What are the vertices? Eris, can you give me another vertice? Vertex?
0, 2.
0, 2. What another one, Eris?
-1, 0.
Okay.
Positive 1.
Yeah, positive 1, 0.
Pardon me.
That's good. And then the last one?
2, 1.
2, 1. Nice. So the way we find a maximum or minimum value is by using what's called the objective quantity, which we'll talk a little bit about today and a little bit about tomorrow. But this is an equation that usually is used to determine like the max profit or the minimum cost, but the goal of the problem would be to find a max or a min using that quantity, whatever the quantity is talking about. And the way you find them is by using the ordered pairs, plugging them in for x and y. So those ordered pairs would give us the max or the min based off of whatever the problem is asking for. So 0, 0 would obviously give us a 0. If you plug in the 0, 2, I have a value of 4. So if that 4 was my profit, I'd be saying that I'm like having a profit of $4 if we were talking about money and objects that we were making. The point 1, 0 would give me a profit or a maximum value of 3. And then the last one, the point 2, 1, would give us a value of 6. So since it wanted the maximum value, the max only occurs at one of those 4 points. It'll never be in the middle. Yeah, it should be an 8. Because I can't add. There we go. And that occurs at the point 2, 1. So if that 2, 1 meant some type of object, that would mean I'm going to make 2 of object X and 1 of object Y to give me $8, if that's what the problem is talking about. And usually those problems they kind of go along with different objects that you're creating, making. Questions? The second problem below there is similar. Looks like a word problem though. So now we're kind of trying to apply the application part to it. And we're looking at a liquid portion of a diet. So it seems like a trendy thing right now to drink like protein shakes, protein drinks. Mr. Warnock.
Oh, he loves those.
2 times a day he drinks some kind of protein fruit shake. So the liquid portion of your diet, and I think he only eats dinner. I don't think he eats much once.
Oh, I asked him the other
He eats
day
some
if
fruit.
if he even ate food, and he said, yep.
And he doesn't like much meat either. He's a pretty picky guy.
How does he know?
He's like this big. Have you seen him?
He eats party mix during study hall.
Oh, does he?
Yes.
Oh, how do you know that?
His son is in the musical.
Oh, he's so cute. He's so cute. And little boy is Mr. Warnock's son.
He's the cutest. His
He's
name's
really
Ashton.
Ashton. Yeah, he's cute. So we got this liquid portion, 300 calories, at least. I don't like if that's all he gets in a day, 300 calories, and then he eats dinner. That's crazy. But he has Chex Mix, so there's probably 300 calories in that bag that he's eating, right? 36 units of vitamin A, 90 units of vitamin C. It says nothing about protein here, so just vitamins. You have a dietary drink, whatever X is, happens to be, gives us 60 calories, 12 of A and 10 of C. Dietary drink Y is again 60 calories, but only 6 units of A, but a lot of vitamin C, 30 units of vitamin C. Set up a linear system that would describe the minimum daily requirements for calories and vitamins. So we know we have 2 different drinks that we're looking at, these dietary drinks. And the X would be the number of cups, because maybe we want to need to drink 3 cups of the drink or 4 cups. I know there's a lot of stuff in there. You need to try and pull together the pieces that are in common with each other and create an inequality with that information. So like reading through it a second time, what pieces could we try and pull together to make an inequality? Kate, you think of an idea?
Yeah, so would one of them be, 300 has to be greater than or equal to 36A plus 90C? Or, so that's what I was confused on, I'm not sure where I would go with that.
What numbers did you pull together? You said 36 and 90. Oh, I see. You're trying to use all of the information in the first sentence. So we do have to do something with the 300. What's the 300 represent? Calories. So, Michael, can you kind of piggyback on that?
Minimum calories you need.
Uh-huh.
So we need to do something with like the 260s.
Yes.
Add up to 300.
Yes. So those 260s represent the 60 calories in 1 cup of X. Do we know how many cups that we're drinking of X? But I know every cup has 60 calories in it. And he said together they have to add up to be at least 300. So Michael, if it's at least, right, greater than or equal to. So kind of piggybacking up there from what Kate had. So the 300 calorie minimum requirement, well, my 2 drinks each have 60 calories per cup. So those 2 cups must at least be 300. So then how can we try and use that to help us get a second inequality? Kate, you think you have an idea?
Yeah, so would you do, 36 is less than or equal to, 12x plus 6x?
Yeah, and I'm just going to flip it on the other side. So she said 12x and 6y. There we go. So 12 units of vitamin A, 6 units of vitamin A for my 2 different drinks must at least be 36. And then the last one, using that same pattern, we have 90 of vitamin C. The first one has 10 units, and the second one has 30. So, like, kind of pulling the same information together. So one has all calories, the other one has all vitamin A, the third one has all vitamin C. So just linking the same types of information together. There's actually 2 other inequalities. We call them obvious inequalities. What can't you have if we're talking about vitamins?
X is greater than or equal to 0.
Yeah. X is greater than or equal to 0, Y is greater than or equal to 0. We're talking about vitamins, calories, drinks. You can't drink a negative amount of a liquid. You can't have a negative amount of a calorie. It's kind of nice if that existed that way. But it doesn't. Questions?
You just eat something and then all the calories get sucked.
Yeah, right? So if you're graphing those 2, because this then restricts it to be a positive value, I'm just gonna make the left side of my graph and the bottom of the graph. So this is like the origin, that left corner.
Miss King, actually celery, because celery, it takes more calories to eat as much.
It's crazy you said that because I think Zach said that 7th period. He said he likes celery. Like, there's no nutritional value. It's almost water. Like, my idea of eating celery is to have it with peanut butter or ranch. Why else do you eat celery?
Zach eats raw tomatoes.
Crunchy. It gives you a crunch in your salad.
I like tomatoes.
Tomatoes are good.
No.
Tomatoes so
I don't know, he
Yeah.
just takes, sometimes I'll get here talking on the phone while eating a raw tomato.
Like,
no.
I don't know. I only like the little cherry ones. I have sun-drop ones in the summer that we grow in the garden, and the girls, like, steal them before I can even get them inside.
You have to get right there.
All right, so let's graph this. If we're graphing it, getting y by itself, Brandon, can you quickly convert that first one in y equals 4?
Y equals negative x plus 5.
Nice, Brandon, that was pretty quick. So taking the x to the other side, we have to subtract it, divide by 60. Y is greater than or equal to negative x plus 5. The second one.
Good afternoon, Northfield students and staff. All junior and senior girls interested in participating in Powder Puff tomorrow is the last day to register. You must submit your completed permission form and payment to the Activities and Athletics office. Also, there is no Jazz 2 after school today. Thank you.
Somebody have the second inequality? Like, what do you have?
Y is greater than negative 2x plus 6.
Good, negative 2x plus 6. So that one goes up to 6. The two lines do connect at that first point once it moves down 1 or down 2 over 1. And Brandon, then the third inequality would be
Y is greater than or equal to negative 1/3 x plus 3.
so 1/3, negative 1/3 x plus 3. So see if you can get that third one graphed. And then try and decide where to shade. Oh, there it goes. That also connects at a point. So if we were trying to get those vertices, they would be really easy to find. Because our boundary line, each like ordered pair connects in a nice location. Where's the area that you're shading? Brandon,
There is
why not?
no. In my obvious example, is that none of the, not all 3 points open up at certain point.
But that's okay.
And also the area above the green line is below the other lines.
So here's above the green line. Here would be above the blue line. Here's above the red line. They're all kind of in that same region. So this whole section at the top, above the x-axis to the right of the y-axis, and then each one of those lines just creates like the boundary. So they don't all have to meet in a point, but they help just create the boundary. Since this says the minimum requirement, that's why it's everything above. If it said the maximum requirement, then it would be everything that would be below. But that's our minimum requirement that we have to drink, not the maximum. Questions? So your homework, if you flip 2 pages and look at page 29, there are word problems on page 29 and 30, 7 of them. You're not graphing those though. So you don't have to go through the graph. Your goal is to just come up with the inequalities and define the variables. You don't even have to get those inequalities in y equals 4. So you're defining your variables. You're listing the 2 or 3 inequalities that might go along with it, and then don't forget about the obvious ones. It doesn't give you a restriction. Sometimes it says you have to at least grow like 10 acres of corn or something like that. One of them talks about corn. Questions?
That would be
Number what?
5.
5. means. And I think the first one is like lettuce and onions. Veggies are supposedly healthier than fruit? I don't know. Maybe?